can start question, comments, or point it out for each of those topics of the paper, or just questions.
I have one question for Dr. Matsumoto. You're using a lookup table to estimate the friction coefficient. So my question is, how much sensitive is the estimation of the friction coefficient to maybe modeling errors in the SIMPAC model, or like the effect of unknown parameters in the simulation?
Yes. Since the sensitive and or the error in introducing from the lookup table to estimation of the mu is different from the case of the inside mu copper. Today's present, I cannot explain the detail of the lookup tables. So if the friction coefficient in inside wheel is small, the estimation is outside friction coefficient is rather difficult. So it is very sensitive. But in the case of the friction coefficient inside rail is not low, I think we can estimate the outside mu. But now I am only the calculation, so further study, I must conduct the low-lying test or on-track test by using real bogie.
Thank you.
Any more questions?
Hello, one question for you, Gianluca. I understood that you control the wheel speed in each position of the track because you know the cant and all the parameters. I understood well?
Yes.
So I have two questions. How do you control it, or how do you expect to control it in order not to have big longitudinal forces? And how do you contrast the centrifugal force?
So we control the motors based on the position of the train on the line. Thank you with the ATO system. So we can know where we are. If we are in straight track, we can do a speed control based on the angular velocity of the motors. While in curved track, we can do a torque control. And so the wheel, they can have the exact torque on each wheel. I didn't catch
But you have a lateral force when you are curving. If you don't have...
Well, how can have lateral force? Well, for the centrifugal force?
Centrifugal force.
Yes, but there is no problem.
But I mean, there were not any lateral forces in these simulations. So when you are running a curve, if you are not running just in the equilibrium speed?
Yeah, I have the lateral force, but I have no lateral force on the wheels because the car body steers the wheel sets, and therefore the angle of attack is 0. The wheel set is aligned to the curve, and so we have no creep force. It's different.
Thank you.
One question to the first speaker, Dr. Mena. What if one of the motors fails?
We are going in a quite safe condition because we are going to have an independently rotating wheel. So a full independently rotating wheel. So we can add sensor, and we can put some speed control, so we can reduce the speed, but we are not safety critical conditions, so the vehicle can reach they can finish the service regularly. So I think it is not it's a problem. It could be something to be investigated in the practical phase, but I think it's not a safety critical point.
I guess you shall switch off the torque on the other motor on the same wheel set, I guess.
Yeah. Yes.
Thank you.
Okay. I like to one question. Okay. I like to ask Mr. G. What is the centering force in such wheel?
How many?
If the wheel move to the one side, how come back to the center?
You don't need to come back to the center because you just use this way to guide. This will support enough guidance. You can just keep you follow the tracker. It's okay.
Same as the independent rotator wheel.
We have a very special mechanical can always keep the direction of the tire. You can if you have if the tire have the direction, it will produce the lateral force and go back to the center. If just this
Lateral force
if you
produced by the conicity.
Yeah. If it's just like if you because you have the angle of this mechanical. If the tire have the angle, if the tire have the angle, it will form the angle. It will form the lateral force. It will keep.
Okay. Thank you.
And Lin from the University of Tokyo. I have the question to the first speaker. So I have two questions about your system. That's when the first one is so if your system that is I guess that your control is maybe the control the rotating speed on the wheel. No. On the speed rotating speed of the wheel, isn't it? No.
I'm sorry, I didn't catch up.
I mean, so okay. I want to know. So it's if you do any special control that you even if your hoisted or bogie passing the traction curve. So because of the straight curve and constant curve and the traction curve, you have in your simulation you have I think it should be this kind of three section. But I think the traction curve it will be quite difficult because. Actually, the contact position on the wheel is not. It will the lateral of the degree of lateral will be changed, and I think the control is not easy. Is the first, and the second question is so is your control is even if the wear happened in wheel, so your control is okay or no?
Starting from the first question. If I understood the traction curve, so the characteristics of the motor of the curve of the curve of the truck.
Traction on the truck. Traction curve the section between the straight line and the constant curve.
During transition.
Sorry.
Okay. So we have during the control during transition between straight and curved track. We can do the same thing. We can apply the same torque transition. It could be quite low portion of track. So there is no problem to apply the same torque in transition. Straight track, same angular speed, curved track, including transition, because its transition is a curved track with various, different variable radius, so it can be no problem to apply the same torque. And for the second question, I didn't catch, I'm sorry.
And I mean sorry, so because it's using the independent rotating, of course it may be so, but if your control is if it's very useful, and then maybe there are no side wear on the flange or something.
Yeah.
But I think even if the damage is lower, but it still have a little bit wear on the wheel, so it means that the real profile will be changed maybe so in the long term. So even if that kind of thing happens, it's no problem. So
Right.
you don't need to tuning your control or something. So it's no problem.
No, I don't think so.
Okay.
One question to
Okay.
Mr. Megan. So your control system works well as designed. In case any maintenance issues, see the control system not working as we expected, is that your without control, your independent rotating wheel can still work safely?
Yeah, there are a lot of independent rotating wheels. Obviously, in the case when a new vehicle is delivered or designed, there are all the possible degradation mode are investigated. So, for example, we will try to see what happens if one suspension fail or if one motor fail. So I think there are no safety problem at this stage. Obviously, when we are going to design the vehicle, all of this kind have to be taken in consideration. But at the design point of view, an independent rotating wheels, single wheels, is not a problem.
Traditionally, from the transit system, they use independent rotating wheel. There are a lot of the derailment issues because lack of the steering force, angle of attack. They cannot
There is
control.
the alignment.
They cannot align.
Hi, sorry, it's another one about the
No.
independent wheels. I just wanted to ask about, you said in curves, you apply constant torque across
Yeah.
the right and left wheel, and I see in a perfect curve that will align perfectly. Does the wheel set respond to irregularities in the track during the curve, or maybe the
If
control system is more complicated than you've told us?
I'm sorry, I didn't understand.
So if there are some irregularities in the
If
track,
irregularities
in
in
the
track,
curve,
no, it's a position based. It's based on the position of the vehicle on the track. So it is not a signal from a vehicle, from the vehicle, or from the position of the carburetors between them. So it's based
So if you
only
have-
on the ATO system. So there is no
so I
regularity
mean,
in the
if
technique.
there's some lateral irregularity in the track compared to its perfect alignment, will the wheel set kind of oscillate a little bit as
Yeah.
it goes through?
But it's possible, but the wheel set will run always centered in curve, because there is the car body will steer, will keep in the position the wheel set.
Okay.
I hope I have answered.
It's almost the time. And thanks again for the speakers, and thanks everybody.